Hi guys, welcome back to my channel and this day 11 of DSA bootcamp and GFC portal and the problem of the day. Today date was 18 July and longest alternating subsequence. And this is my current streak 332 and let's solve this. Mm, okay. The difficulty category of medium. Let me go through the question and then explaining everything and then you are given an array, and your task is to find the longest length of the subsequence, subsequence. And good sequence is that x1, x2, so on, so on, so forth, and up to the xn is an alternating sequence if an element satisfies to one of the following relationship. If a two relationship is given, either it should be the first element should be smaller than the second element, and the second element should be greater than the third element, so on so forth, alternating fashion, nothing more. And 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 either first one should be small or it can be an increasing. First element should be greater than the second element, and second element should be less than the third element. Like that, the alternative fashion, any one of the conditions should satisfy alternative way, and we have to find the maximum length out of it. I hope you got the answer. Let's try run few examples, sample examples. You got to know. For example, here the one is less. It follows the first rule as 1 is less, x1 is less, and x2 is more, 5 is more. And here 5 is more than the x3, 5 is more than the 4. So it satisfies the first relationship. So the maximum length is 3 elements, 3. And coming to this, as you can see 117 and 10. If you see why we are not taking subarray, because as the question states that good sequence means that we can skip few elements, and we can ignore few elements intermediate, and we need to consider only but relative order will follow. That's the main thing on sequence, any subsequence or anything. But when it comes to subarray, we should not skip any element. It should be an continuous fashion, and it should follow the relative order also. And here we are taking 1, 17, 10. See the output 1, 7, 10. As you can see, 1 is small and 17 is more, and 17 is greater than 10. Alternative way, all ups and downs will be there. So whenever you form some kind of an, graph, let me go to the notepad and let me take the highlighter. Like if you form a graph, it will be displayed like this, like sinusoidal way. When you study any inter or something, there is concept of sinusoidal way. Using the tan theta, you can able to trace it out. What was the maximum deviation of the probe? And, with the help of that, we can able to solve in multiple approaches when it comes to any subsequence, the longest subsequence. And here comes the alternative way. We have to find out the maximum, and you can able to solve. There are a lot of sub problems inside that. For example, here in this case, we can skip few elements. We can take few other elements. For suppose if we take 17, from 17 to up to, yeah, we can take that 17 is the maximum one, and 5 we consider 5 is smaller, and this smaller should be greater than 10. This element also valid. It will be above the relation to. So it can be many forms with there and many subproblems inside one array itself. So we can directly use any recursion approach, and then we can optimize using dynamic programming and memoization, and the space optimization also, which we can do. This one approach using dynamic approach by solving subproblems first and then solving the bigger problem, and after that another approach will be the greedy using a two-pointer approach we can able to solve. Let's discuss about the first problem, which is nothing but recursion, and on top of it we can do the caching mechanisms like memorization comes into the play. Basically, this is a given input question, array is given. You have to find the length, and this is a cache. When it requires, whenever we want to optimize, then only this cache will appear, and it doesn't recompute, recalculate the sub problems again and again. It will store in one array and it will return back whenever we need it. And we are taking answer result, and every time we have to find the maximum out of it out of all the sub problems. So that's the reason. Here DP is nothing but a recursion call. As you can see, the recursive function with the memorization optimization DP, and which consists of number and ID indicate index and previous type. Here we have two types of operation. Zero will be the first the first way. Here I was mentioning this as a zero type and this has a one type. Okay. And same thing, we have to store in a two-dimensional DP matrix. And previous step indicates a 0 or 1, it will be range slice. And memorization stores the subproblems of individual subproblems also. And we are checking whether the index is 0. We can simply take one of the single length because a single element contribute to the one length itself. It's a base case. And after that, we are checking for the if it is already been computed, no need to recompute again. We can simply return back the stored answer, which is stored in memoization result. And max length, initially we should set to 1, and then while iterating we can check for the max out of it every time. And here, as I said, right, two cases, uh, previous type of 0. 0 is nothing but the first relationship where the x1 is less than the x2. Same thing follows here. And previous type 1 indicates the opposite case, x1 is greater than the x2. So this is the case. If any one of the relationship is satisfied, then we can simply go ahead with that, and we can take the maximum length and we can add one to the answer, the current answer, and check the maximum out of it, and we can store in the memorization result for every elements and every subproblem results, and we are returning the maximum length out of it. So here the DP problem will return maximum length for every subproblem, and then we are getting the answer. This is one approach using pick and not pick approach. Same thing. And memorization is done. Now coming to the dynamic programming is nothing but a bottom-up approach. Here the recursion is top-down approach. So in this approach, we are using the same mechanism, and we are showing DP matrix of vector of x two-dimensional. One will be the size of rows, will be the number of columns, number of elements, and two will be the two operations which we can have. So initially we are setting to one, maximum length of one, and then we are using bottom-up approach and using two traversals, two for loops. One will be starting from 0 and another one will be starting from -1 onwards. And we are checking the condition whether the particular element and the j is should be less than the adjacent element should be less than the first one. And if we found the maximum length of it, then simply take and assign the maximum value out of it. Else if condition for the type 2, we have to check for the x1 should be greater than x2, and the length should be greater than the previous length should be greater than the current length, so that we can store the maximum length of it. And every time we are checking for the maximum, and we can compare with the maximum answer. And these two operations, either taking the first type or the second type, the one type. If whatever we are getting in the maximum, we are storing in the maximum and returning that. As you can see, we are stored in a one vector. We have three elements out of it: type 0, type 1, and the comparison annual result maximum value. And this is the third approach where we can solve using two pointer approach. It comes under greedy algorithm. By using two pointers, one will be the incrementing and another one will be the decrementing. which represent the length of the increasing and decreasing sequence ending at the current element, and updating the current pointers based on whether it contribute to the increasing or decreasing sequence. And finally, we can result by the maximum of two counters, which represent the maximum. Simply states that we have two pointers, one will be the upper and second one will be the downer. Upper will indicate the maximum, all are in ascending order, and this to the descending order. And we are traversing through the I pointer, we will be traversing entire array and checking the adjacent element. And if the adjacent element is more than the previous element, nothing but the comparison, instead of the we can compare with 0, which means that adjacent element is more and this one is less, which means that it was in ascending order. So we are assigning up equal to down plus 1. Initially we set 1, right? 1 plus 1, up will become 2 here in this case. And after this case, again the second iteration will comes here and it will check whether if it is a negative phase, which means a down phase, then we can ascend down equal to up plus 1. And for every iteration we are moving ahead, we can simply we can remove the while loop and we can use for loop also, using which we can avoid multiple steps. And after that we are returning the maximum out of it, both the pointers. And the time complexity is order of n linear, and the space complexity is I was using constant space of variables, no additional spaces, no additional data. For this approach, it will take n square solution as we are iterating twice, and DP also take, and additional memory also will take for DP. And as you can see, constraints are 10 power 5. So we should, at max, we can go up to n log n only. And at the worst case, to run in 1 second in on servers, any test cases. And yeah, that's all. Yeah, please like and share and subscribe.